Hello everyone, I hope you are doing well. Today we are going to talk about strings. So let's see what is a string and why they are useful and how we can use them in C programming. As you can see, whenever we want to show strings, we can't put them inside double quotes like this. We use it for printf, for example, if you remember. And we can define strings inside arrays as well. So the elements of arrays are not necessarily just integers and floats. They can be also characters. And you see, whenever we talk about characters, we show them inside the single quote, and we should be careful about that. So the whole thing, you can show it by using double quotes. You can write your sentence. You can even type the whole paragraph. But when we talk about just a character, it means that one single letter of each one of your words, and you can define each one of them inside characters. So each one of these characters can be elements of your array. And since now we know about arrays, now it's the time to talk about strings and how we can use them inside arrays as well. So we already know about printf and scanf. The equivalent in strings we can mention about gets and puts. So for example, when you use scanf, you remember you could get information from the user, for example, float numbers, integer numbers, and you can even get strings characters from the user using scanf as well. But there is a simpler way that you can use, which is this one. Or if you want to get only one single letter as a character, you can use get char, so that easily you can get it from the user. For printf, the same situation. These are the equivalent ones. When you want to just get the whole message, then you use put. And whenever you want to just print out the result for one letter, then just you can use this one instead of printf. So for reporting, you use this one to tell the user what's going on about the information that you want to report, and these ones for getting the information from the user. Let's see how we can initialize strings. So we define them as arrays. As you can see, it was the way that we define arrays, by just mentioning about the name of the array and the size of it. Now this part now is different. Let me also use this one so that you can see it easier. Yeah, so for character we use char. So char, it shows the variable type, which is a character, and the name of the array and the size of it. So when you want to initialize it to say, okay, what are the elements inside this array, then you can use double quotes as we mentioned, and you just type whatever your message is. And you can even leave it empty. If you leave it empty, it means that the size will be decided as soon as you type it. So maybe you don't know exactly what's the size of your array. Then you type your message, then automatically it will be considered as the size of the letters that you enter. But remember, as the previous slide described, we always end our strings with /0 as one character. The whole thing here is just one character. And why is that? I will show you in one example today that why we want to end our array using that. So when you type your message like this and save it inside the array, automatically it will consider /0 after it anyway. So you see here, we didn't type it, but automatically it defines it. And we should be careful. Now you just type 4 characters, and we should define the size as 5, so that we should consider this one as well. Or just leave it empty, and as soon as you type the message, then automatically the size will be decided. or one by one, letter by letter, character by character, you can define like this. This one is very similar to the way we define it for integers and float numbers. You remember you used these curly brackets. We had comma between each number. Now we should be careful to use this single quote. This one shows that this is a character. Now if you here type a number, for example 2, 5, whatever number you type here, it considers it as a character. This is different. That's why it will be saved in this format. So you could use one by one, and you could even don't mention about the size of it, and automatically it will be 5 like this one. So all of these things will produce the same array. No matter which type you prefer, they will produce the same result. So we already mentioned about gets that this is equivalent to scanf. You can use this one to get information from the user. It's easier because you just type the message and that's it. You don't need to mention about percentage %s, for example, percentage %c. And let me show you also later in one example about it. Okay, so take a look at this example. Here we define m size as 81. As you know, you can even use this one before the main function. That's usually what I prefer because we already talked about global variables and you already know why these blocks are important. But since this is a simple one, it doesn't matter if you define it here or before the main function. So this is the way now we're defining the array which contains characters as its elements. So the name of the array is message, m size which is 81, and the type of it is character. Now we ask the user to enter a string, and now you see instead of scanf, easily you can use gets and message. That's it. There's no need for percentage sign, there's no need for and sign, and we will also compare it later. So you get the message from the user, then you said the string just entered is, then you use puts instead of printf. And easily, whenever you have the array which is in format of character, then you can use gets and puts like this to get information from the user and report it like that. You receive the message, you report the message. So let's take a look at puts and printf and how we can distinguish them. So both of them are doing the same thing. So you see, whatever you did before, we can do the same for strings. But instead of %f or %d, now we have %s. So when you use your array here, you mention it here, then don't forget to use %s, or simply just use this one, which is easier. And take a look at this one for scanf and gets. For scanf, there's a difference between the formats that we usually used for scanf. If you remember, for assigning values, we used and sign here, right? Whenever we had a scanf, we had and sign. For arrays which contain characters, we don't use that and sign here. But in order not to confuse it with other scanfs, just simply use gets for strings so that we don't forget about the and sign here. Okay, there's a header which is very important, and we will also mention it inside the examples, but there are just some functions here. As you can see, the output, we usually mention it before the name of the function, and the input types. You can see asterisk signs here. Don't be confused by them. Usually, whenever we use pointers in C programming, we use asterisks like that. We don't want to go deep to pointers for you guys. For computer engineering students, usually we should dive into it and talk about different types of pointers. But for you guys, just to know, whenever you use asterisk signs, it means that this is pointer, and This is good for memory allocation in programming languages. So we don't care about it that much in our course. Even without using it, we can define it, and you will see in the examples how it happens. So even without considering them, all the things that you know is almost the same. They are just input types, and this is the output type. And here you see constant characters. Why is this one? Again, this is related to the way we define pointers. So it shows that it will be remain constant throughout the program. So don't care that much about this part, but we should know about each one of these functions, that what they are doing. Their job is important. So this one, strcpy, it copies whatever you have in string 2 to string 1. So this is the job of this function. So whatever we have as a string array here, we copy it to S1. Then we report the value for S1. If we want to exactly specify how many elements of S2 I want to copy in S1, this is the way to do that. So here we just mentioned about the number. That's it. The next function, strcat. This one adds S2 to S1. So for example, if S1 is hello and S2 is world, now together will be hello world. And whenever it happens, the /0 at the end of the array will be eliminated automatically, and we will just keep the /0 at the end of this array. So together we will have hello world, and you can print it out for the user. And again, if you want to mention exactly how many letters from S2 you want to add to this one, then you can say about the number of elements here, which we will see in the examples, and they will make sense for you. They are pretty easy. And this one, strcmp, this one we use to compare two strings together. And when we say about comparison, it's very important for us. Sometimes we want to check if two texts are exactly the same. For example, when you enter your password in different websites, if you paid attention, sometimes they ask you to re-enter your password. So if those two passwords are not identical, then it will give you an error and ask you again to enter your password. So this is how it works. We compare them together if they are the same or not. And even we have the expression to say one of them is bigger than the other one. But how do we measure that? It's related to alphabets. So whenever, for example, the order is stronger, then we say, okay, this one is bigger. For example, A is bigger than B. B is bigger than C. So A, B, C, D, we go through the whole alphabet and X, Y, Z. So let's see how we can see that in this example. So we assume that we want to compare these two together, goodbye and hello. We start from the first character. So here we mentioned G is less than H. Why is that? A, B, C, D, E, F, G, H. So let me also correct it. In the previous one, I said when order is stronger, I meant that if A, for example, happens before B, it means that this is less than that. So A, B, C, D, E, F, G, H. H comes after it. So G is less than that. So whatever comes after it is actually considered to be bigger. So let me rephrase that about the last slide that I mentioned. A is bigger than B. No, B is bigger than A. C is bigger than B, and so on. So here, because in alphabet, we see that H comes after G, so G is less than H. So when we compare these two strings together, element by element, we compare first G and H together. If they are identical, and then again we move on to the next letter, but they are not identical. G is different from H, and H is bigger than G, and G is less than H. It depends about the order that we compare them. Again, in the example, I will show you better. And as I said, sometimes we use numbers as characters. it can be useful. For example, when we want to convert one character to variables like integers or floats, then we use these conversions, and these are important. So the way you define them is important. 1, 2, 3 that we defined here is not a number, it's the character. So when we compare it with this one, the comparison is very similar to numbers, because clearly 123 is bigger than 122. So the same situation happens in characters. So one by one it compares it, and when it reaches 3 is bigger than 2, and that's the way the comparison will be made. So these examples now are important so that you understand what I was talking about related to these functions. So take a look at these ones, and you see we have a header here, string.h. If you don't type this one here, C doesn't understand what is this function. So it's very important to include string h so that C understand what is this function, for example. Now, whenever you use void here, it means that you can remain it as empty as it was in the previous programs that we had. So they are the same. It shows that the input is void and output is int. Output is int, and that's why we have written 0. 0 is an integer. But as we said, for the main functions anyway, we use the same format all the time. We don't want to pay attention to it that much because it's always repeating the same. Okay, so first thing, we define these arrays. So the first one, we didn't mention about the size of x, but here we type our sentence. So happy birthday to you. It counts how many characters it has. Even spaces are counted. So be careful. Between happy and birthday, we have a character, which is a space. This is empty. And at the end, automatically, we will have a /0. So for the next array, again, we define the name of it and the type of it, which is character. The size is 25. We don't mention about its elements. Maybe later we want to define it. So you can just finish it here without mentioning about its elements. Then look at this printf. %s, then /n, we go to the next line, %s. So whenever you see that, we should go to after the double quotes to see which one corresponds to what after this comma. So this quotation, as you can see, the whole thing corresponds to %s here. The next %s, we define it as string arrays, x, which is happy birthday to you. The next one, again, we type the whole thing like this. And the next one, we have this function. So what was this one? We copy whatever we have from x to y, and we report the result for y. So what we will have? The first sentence, happy birthday to you, which is x. The string in array y is, then we have that function, which is the copy of the x. The copy of x is assigned to y, and we print out the result for y. So from now on, this one is defined to be happy birthday to you. All right, next one. Here we specify exactly how many elements from x we want to copy to z. So not all of them, not the whole sentence, happy birthday to you, we want to copy to z. Just 14 of them. So we count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Happy birthday. Just this part. Okay? So as we said, spaces are considered as characters too. All right, so let's go to the next one. Again, don't forget to include this library string header. We define 3 arrays, and all of them are characters or strings. So for the first one, we have happy and a space. And you see we define it 20. So when you define it like that, the rest will be just empty and it doesn't consider it. So the next one, for example, you see this is empty, so automatically it will count how many elements you enter. So we will have New Year to be assigned to S2. And for S3, we just mentioned that this is empty. You can even just use semicolon here. You don't even need to show it like this is empty, but this is just a way to show you that we can show this is empty like this. Okay, so S1 is equal to percentage %S. So you see, whenever you put it inside double quotes in printf, C doesn't care what you type. It exactly prints out whatever you type, but as soon as it reaches percentage, then it will check it, whether it knows this letter or not. Percentage %S corresponds to strings, as we mentioned. So this one corresponds to these, and the next one corresponds to the second component. So first array, second array, we print out each one of them. So happy and New Year together. So here is what you have. So happy and New Year. If you want them to put them in the same sentence, then we should use this function. So why it happened to be in the next line, here we decided to be in the next line. If you wanted to just print it out in the same line, again, it looks like somehow you use this function, but you didn't actually. Because when you use this function, from that time, S1 will be the addition of S2 to S1 from that moment. So sometimes we want to avoid it too. Okay, in the next one, as we saw in the output, we type this one. C doesn't understand what is this. It just prints it out. And from this part, the percentage %S, it corresponds to this function. So what does this one do? It will add S2 to S1. We didn't even limit it to a specific element. So Happy New Year will appear here. The addition of these two together. All right, next one. Here we mention exactly how many elements we want to add from S1 to S3. How did I understand? This is not comparison. This is not, for example, copying from this function. The name of the function we should remember. So we add 6 characters of S1, which is 1, 2, 3, 4, 5, 6. So the whole thing, happy, will be added to S3. But S3 was empty. So the new S3 would be exactly this word happy. The next one. Okay, let's print out this one. Oops, I'm hearing my voice. I hope it's not a problem now. Yeah, it's fixed, I guess. I hope you guys are hearing me well. If not, please let me know. Okay, so when we want to print out this function, then S1 will be added to S3. But S3 is already happy. So C remembers that whenever you use this function, it will be saved in S3, exactly like the variables that we had before. Like when we define x was equal to 1 in the same block, the next time when we add 1 to the previous value of x, it remembers it. So it will be 2 the next time. And this is the same story for strings. So it remembers that last time when you use this function, now S3 is happy, not just the empty array. So for the next time when you add S1 to it, it will be happy New Year. And we didn't limit it with a number, so the whole string for S1 will be appear after that. Okay, let's take a look at this one. So you see, we say initializing char pointer. So as we said, for pointers, we use asterisk before it, but for you guys, you don't even need to use it. Just simply define char S1, and you can define the arrays as we did in the previous examples. So in the practical assignments, you don't even need to use pointers, but just for you guys to know, because it is in the syllabus that at least mention about the pointer, that how they look like in your programs. So instead of constant char, you can use just char S1, and you mention about the size of it and the strings. So you see the difference is that we don't even show the closed brackets here as a square brackets. So we define them as these strings. These two are identical. The last one has holidays instead of New Year. Now we want to print out the whole thing like this. So S1 equal to the array. This part, as I said, C doesn't care about what is this. It just prints it out as it is. Don't forget to use %s for it as a string it wants to print it out. S1 as an array, which we defined here as pointer, will be print out. So it will be exactly this sentence, Happy New Year. So we do the same for S2 and S3. So in the output, you will see S1, S2, and S3 as this. So next one, you see we want to practice the comparison function now for strings. strcmp, so this function is used for comparison of strings. And as I told you, it's especially useful when we want to compare two strings together if they are identical or not, but it has a specific usage for comparing them, either they are less or greater, as we mentioned before. In this example, we will practice it carefully. So let's compare S1 to S2. We know that by using this function, it can be happened. And when they are exactly the same, it checks it from the left side one by one. H is equal to H, A is equal to H, empty is equal to empty. So until the end, all of them should return the value 0. So you see, the answer of that is integer. So it will be either 0, 1, minus 1. Whenever this is greater than, this is 1. Whenever this is less than, this is minus 1. Let's check it, how it happens. When we compare S1 to S3, so Happy New Year is compared with Happy Holidays. So until these characters are exactly the same. So N, H. So when we compare it together alphabetically, A, B, C, D, E, F, G, H. So H is coming before N. So it means that N is bigger than H. So what should we return? 1, not minus 1. Okay, so this one will return 1. And the next one, so you see order matters. We use exactly the same strings here, but we mentioned compare S1 to S3. Compare S3 to S1. So it means that now compare H to N. So H is less than N. What should we return when this is less than? This is minus 1. So here is the result. In the next functions, we want to specify exactly how many characters of each strings you want to compare. So here also we can use this one instead of going to the previous slide. They are the same, right? So here this function says that compare S1 to S3 in the first 6 characters. The first 6 characters are the same anyway. Happy plus space, they are the same for S1 and S3. For next one, we compare S1 to S3 in 7 characters. It means that again N and H will be compared. So we will have the same result here. If this is 1, this is again 1 here. But if we, for example, type here 6, the return will be 0 as in the previous one as you saw. If it is, for example, 2, again 0. If it is 4, because happy is the same in both of the strings. Now S3 to S1. Again, since you are comparing H to N now instead of N to H, so the return will be -1. So these are some functions which can be very useful in order to uh, investigate through our text and through our strings. And you see, we have output integer like the previous ones that we saw. For example, 0, 1, -1, they were integers, although the input was in char type. These two, pay attention that these two, I think it's better to change them to char as well instead of integer, because we want to return characters instead of integer. Please go through all of them carefully. They are very useful. We can see also examples as just a single character, how we can use it. For example, we can check whether your text has any uppercase or not. We can check, for example, if you have any digit inside your text or not. So these ones are very useful. Please go through all of them one by one, and you will see one example related to it after it, and we will talk about it in details. But the last two one, as I suggested, is better instead of integer, use char, so that for example, when you want to convert something from uppercase to lowercase, like this one, we want to get a character, not an integer. All right, so let's go through our last example, which contains also that we mentioned. And those functions in the previous slides, we should use this library, C-type header. Okay, so don't forget to mention about this one if you want to use those functions. Here we didn't use a string header because we don't want to use comparison or copying as in the previous examples. So here we defined max chars 100. So the maximum characters that we can have is 100 inside this array. So here is the way that we define arrays: the name of the arrays, the type of it, and the size of it, and the function prototype. This one I usually suggest you use it at the beginning of your function or before it. So it's up to you. But don't use it after the main function for sure. Personally, I prefer to use such constants, defining such constants, and using these functions prototype before it. So why function prototypes are important? Because from the beginning you mentioned that what's the output, what's the input type. So the types of them from the beginning is shown. So when I see void as output, if you go through your lecture 6 carefully, you understand that at the end you don't return an integer, for example. What you return is a printf situation, right? It's like you are printing out something. And you saw already in lecture 6 that what's the difference if output is void, if it is integer. Again, in worksheets and lab exercises, please go through them to distinguish between them. And whenever I want to return, for example, a number, here I use integer output, and we define it accordingly inside the function header. So next, we ask the user this: type in any sequence of characters. Then we use gets instead of scanf. It's easier. You could also use scanf, but this one is easier because you already define it as string. So this is string array. We get it from the user. He just types it, and then you convert to uppercase. So whatever you have inside this text, you use this function. But I should know exactly what this function does. It's just a name. So whenever you want to check it, you should go to the function header. Here, after the main function, define your function header as we did in lecture 6. So again, here we mentioned about the output, about the input, and take a look at this prototype and compare it with the header. Here, not necessarily you mention about the name of it, but here you should mention about the name. So because it's important when you want to show it inside the body of your function header, when you say message, here it appears too. So it should understand what's the name of it. So you define I as integer because we want to define a loop here. Pay attention to the way that we define this loop. This is very important. So the initial one is 0. It continues until one of the elements is not equal to /0. And this is exactly why we use /0 at the end of the string arrays. So that it's very useful whenever you want to define a loop. We know exactly when it will be end. So this is the end of your array. So it means that from the beginning of your array, go to the end of your array. And this sentence, you use it a lot. So once you see it, the next time it's very easy to use exactly the same command in your programs. So this statement is important. Please go through it to understand what it means. So one by one, the trend is one by one from 0, the position 0 in your arrays, go to the last one. So whenever each element of your array is equal to the uppercase version, what is this one? In the previous slide, you can see what this one does, right? So it changes everything to the uppercase. So what it means? It means that one by one, each element by element, you check whether this element is uppercase or not. If it is equal to the uppercase version, it means that it was already an uppercase. So that's the way we can detect all the uppercase ones there. Why C understand what this one means? Because you didn't define it by using this C type header. That's why it's very important to include the libraries which are related to your codes here. Otherwise, C doesn't understand what is toOpper function. You use the predefined function inside another function, which is very useful. That's why libraries can be very useful, because as you know, it's not easy to define a function in another one. Then we should use it usually when you call it inside the body of the function. All right, so what we have done, first we define the constant, the string arrays, the prototype of the function. Then we ask the user to enter the characters. We got the characters from the user. We called this function. What this function does, it received the message already from the user, so it checks whether the letters are actually uppercase or not, and make it equal to that element. So if that one was not uppercase, for example, if you have lowercase a, this one makes it uppercase and assign it to message I. So the job of this function is not necessarily checking whether those two are equal. It assigns the uppercase into the lowercase if that's the one. So it checks first a lowercase a is equal to, for example, uppercase A or not. Then it will assign it. If it is already there, even if it assigns to it, it will be receive the same result anyway. Because usually when you use this equal sign without using a double equality, it replaces it anyway without checking even they are equal or not. But this is just in our mind. But computer doesn't understand it, and it just assign whatever you have there. So this is the way to convert all of your message into uppercase. And how did we do that? By using this function defined in the loop. We did it one by one because this function is only capable to do it using just one character. So character by character, element by element, it can do it. It cannot do it for the whole message. So that's why we needed to define the function ourselves in order to convert all the letters from that text into uppercase. And as I said, this statement is important because this is the way all the time we check from the first position of your array to the last one, which is /0. Okay, guys, I hope this lecture was useful for you. We will have a 10-minute break. After 10 minutes, we will take your questions.